Hello, dear students. I am glad to meet you at our course. Today we are going to discuss trusses. Let's start. A truss is a structure that consists of members organized into connected triangles so that the overall assembly behaves as a single object. The wood trusses that we so commonly see today are triangular units joined together with galvanized steel connector plates. This structure distributes weight to supporting structures such as load-bearing beams, walls, or the ground, and the handling of changing tension and compression without bending or shearing. The triangle is geometrically stable when compared to a four or more sided shape, which requires that the corner joints are fixed to prevent shearing. Typically, the joint connections are formed by bolting or welding the end members together to a common plate, called a gusset plate. All external loads acting on a truss are assumed to be acting only at the joints, and therefore all members of a truss are two-force members. The individual members are not subjected to bending moments and shear forces, but are subjected to only axial forces that are either compression or tension. A truss is a structure that is very often used in civil engineering, such as bridges, steel buildings, towers, and roof structures. They also appear in many mechanical and aerospace structures, such as cranes, offshore platforms, space structures, and so on. In 1952, in Pompano Beach, Florida, after experimenting with plywood gusset plates and varying concoctions and combinations of glue, staples, nails, and screws, the metal plate-connected engineered wood truss was invented and patented. The inventor, Carroll Sanford, founder of Sanford Industries, marked the beginning of the truss industry that is still changing home, apartment, and commercial building construction all over the world. In general, trusses are used to achieve long spans, minimize the weight of a structure, reduce deflection, support heavy loads. Trusses are typically made up of three basic elements: a top chord, which is usually in compression; a bottom chord, which is usually in tension, also known as I-joists or ceiling joists; webbing, posts. The top and the bottom chords of the truss provide resistance to compression and tension, and so resistance to overall bending, whilst the bracing resists shear forces. The efficiency of trusses means that they require less material to support loads compared with solid beams. Generally, the overall efficiency of a truss is optimized by using less material in the chords and more in the bracing elements. Usually trusses are made of steel, timber, and very rarely from concrete and aluminum. Timber for trusses must be high quality and able to tolerate high amounts of stress. Most wood is stress-rated by machines, which grade its quality. Plates are a secondary material in trusses. They are sturdy pieces of metal, typically galvanized steel, that are used to hold the wood together at joints. Plates transfer stress from the wooden beams of the truss to the joint. This allows the truss to tolerate more weight. In buildings, trusses allow engineers to create large open spaces with fewer materials. Using fewer materials also allows contractors to build cheaply. Spaces in trusses allow pipes and wires to easily pass through the ceiling. Despite being specific in design, there are many different types of trusses that engineers can use. This allows them to be creative and to include structures such as vaulted ceilings. In both buildings and bridges, trusses are popular because they are incredibly strong. In fact, wood trusses are often used with concrete, a material considered much stronger than lumber. Many different styles of trusses exist today. The most common trusses are the how, think, and triangular trusses. They are relatively simple and generally do not extend beyond 10 feet. There are a wide range of truss forms that can be created, varying in materials, overall geometry, and span. Some of the most common forms are described further. Pret truss, also known as an end truss, this form is often used in long-span buildings with spans ranging from 20 to 100 meters, where uplift loads may be predominant, such as in aircraft hangars. A pret truss uses vertical members for compression and horizontal members for tension. The configuration of the members means that longer diagonal members are only in tension for gravity load effects, which allows them to be used more efficiently. Warren truss. A Warren truss has fewer members than a pret truss and has diagonal members which are alternatively in tension and compression. The truss members form a series of equilateral triangles, alternating up and down. No-fly truss. This form of truss is usually used for short spans in industrial buildings and is so called because it allows maximum benefit to be gained from natural lighting by the use of glazing on the steeper north-facing pitch, sometimes referred to as a saw-tooth roof. It is common on the steeper sloping portion of the truss to have a second truss running perpendicular to the plane of the north-light truss, providing large column-free space. King post truss, typically made from timber and spanning up to 8 meters, king post trusses are commonly used in the construction of domestic roofs. They take the form of a simple triangle with a vertical member between the apex and the bottom chord. Queen post truss, similar to the king post truss but with diagonal members between the center of the bottom chord and each of the inclined top chords, queen post trusses can span 10 meters. Flat truss. The top and the bottom chords are parallel, allowing the construction of floors or flat roofs. Thank you for your attention, dear students. Next time we are going to study roofs. See you next time. Goodbye.